In this video, we'll discuss the special relationships in a 45, 45, 90 degree triangle. So to illustrate this, we'll look at the diagonal of a square that forms two congruent isosceles triangles. So if we put a diagonal here through the square, we get this triangle, and we also get another triangle. And they're both going to be isosceles. They have two equal sides. And the measure of each acute angle is going to be 90 divided by 2, because there's 90 degrees left to distribute between these two angles, which must be equal because they're across from our equal sides. So each of those smaller angles, the base angles, are going to be 45 degrees. This triangle is known as a 45, 45, 90 triangle. You can use the Pythagorean theorem to find a relationship among the side lengths of a 45, 45, 90 right triangle. So if we call our big side the hypotenuse, right, because that's the one across from our 90 degree angle is a hypotenuse, and then we'll call the two bases L for legs. So our Pythagorean theorem says that a squared plus b squared equals c squared. So our legs are the a and b, and then our hypotenuse is our c. So we'll say L squared plus L squared equals h squared. That's our Pythagorean theorem. And then if we combine our like terms, we get 2L squared equals h squared. And then we can take the square root of both sides here to get the square root of 2L squared equals the square root of h squared. And we can factor out an L because we have L squared. So we have L times the square root of 2 equals h. And this algebraic proof verifies the following theorem. So our 45, 45, 90 triangle theorem says that the legs are congruent and the hypotenuse is the square root of 2 times the length of a leg. So our equation in a 45, 45, 90 triangle is that our h, hypotenuse, is going to equal length times the square root of 2. Let's take a look at a couple examples. So this one says, find the hypotenuse length in a 45, 45, 90 triangle. All right, so since we know we have a 90 degree angle here and 45 degrees here, our angle here must be complementary, since it's a right triangle, complementary to this angle of 45. So this angle is going to equal 90 minus 45, which equals 45. So we have a 45, 45, 90 triangle. And then we can use the theorem we just discussed, theorem 8.8, the 45, 45, 90 triangle theorem. That tells us that h equals L square root of 2. So hypotenuse equals leg, the size of the leg, times the square root of 2. And we have one of the legs here is 6, so h, we'll substitute 6 in, for L equals 6 times the square root of 2. And next, we'll do problem B. So we have our legs, so our equal sides here, 9 square root of 2. If they're equal sides, and we know we have a 90 degree angle, then these two angles must be 45, just like the last triangle we discussed. So we'll use the same equation, h equals L square root of 2. So we can plug in our L, h equals 9 square root of 2, square root of 2. And the square root of 2 times the square root of 2 equals 2. So we can rewrite this as 9 times 2 equals 18. So our hypotenuse equals 18. Let's look at one more example here. So we can also use backwards using theorem 8.8 to find the lengths of the legs of a 45, 45, 90 triangle given the length of the hypotenuse. So let's take a look at that here. So once again, we have a 90-degree angle here. So we know that these two are complementary, so they add to 90, and they're equal because they're both across from a side length that's equal, which is x. So we know these are 45. So we have a 45, 45, 90 triangle, and we know that h equals L square root of 2, and this time we have h. We have h is 12, and our L is x this time. So 12 equals x square root of 2. Now to get x by itself, we'll divide both sides by the square root of 2. And we get x equals 12 over the square root of 2. And I switched the order of the x and the number because I like having the variable on the left side. So x equals 12 over the square root of 2. Now we can simplify this to get the square root out of the bottom by multiplying by square root over 2 over square root over 2, which is the same thing as multiplying by 1, so we're not altering this equation at all. So we get x equals 12 square root of 2 over, and the square root of 2 times the square root of 2 is just 2. And we can simplify that because 12 divided by 2 is 6, and then we still have the square root of 2. 6 square root of 2, and that's our x.